Welcome to this episode of Intellectual Conservatism. Today I'm here with Dr. Nigel Cundy. He is the author of the book, What is Physics? A Defense of Classical Theism. It's over 700 pages. I bought my copy recently. I love it. I haven't had time to completely read it, of course, with all the craziness of COVID-19, going back to college and so forth. But I'm so excited to be ending the summer series of Intellectual Conservatism interviews with Dr. Cundy, or Nigel. So Nigel, can you introduce yourself to the audience?
Yes, so my doctorate and my work as an undergraduate was in theoretical physics, where I do work on the standard model of particle physics, particularly numerical simulations. Now, just to give you a bit of idea, if you look at, say, the atom as something we might all be familiar with, if you go down a little from that's a nucleus with some electrons orbiting around it, then the nucleus is made up of various particles, and then those particles are made up of quarks and gluons. So what I did my research on are the interactions between these quarks and gluons. So that was a number of years ago when I started this, and then I went off to do some postdocs in Germany, and then went on to South Korea before coming back here to the UK. So my second interest is in classical philosophy, which I probably started during my first postdoc, so some time ago. Now that would be the mid-1990s. The mid-2000s. Decades out. So that started off this, and I wanted to read some early Christian works, and that's got me interested in classical philosophy, and in particular classical theism. So gradually, over the course of a few decades, those two streams, or a decade or so, those two streams came together and eventually resulted into the book, which I first published a few years ago.
Yeah, if you don't mind me asking some questions about the book, I mean, one of the things I noticed was that, it's a massive book and you write a lot, and it's in small font and it covers almost all of the pages. How long did it take you to write that book?
Well, it was a number of years. I had, it was mainly, let's say, I probably started it intending it to be for a different purpose in about 2013 onwards. I mean, and it gradually built up. And the main writing spree was for, I don't know, a couple of years leading up to 2016. And then there was obviously proofreading, editing. So it took some time. It took 5 or 6 years. But the ideas behind it, as I say, I've been working on for a decade at least beforehand.
Yeah, one of my friends who's a graduate student, he wanted to know why you self-published instead of like going to, Oxford University Press or an academic publisher. He was just interested.
Yes, because my book doesn't really fit into any of the neat categories that a publisher would look at. So I reached out to a few publishers, but then is it a book about physics or is it a book about philosophy? So the philosophy publisher said there's too much physics in there. The physics side of things said too much philosophy. So it doesn't really fall into any neat category for an academic publisher. And it's not really a work for a layperson.
It's its own category in some sense.
Yes. So it was a bit difficult to find a publisher, so I just decided to go for self-publishing route.
All right. Well, I'm excited to kick off this episode. I remember a lot of my friends, they were actually saying this is one of the interviews that they are the most excited about. So, I mean, you have a growing number of followers, Nigel. So let's just begin by talking about the beginning of the book. So at the start of the book, you talk about some tools that we can use on our journey, right? You talk about logic, probability, the scientific method, and then you also introduce the readers to metaphysics. So I wanted to kind of touch on why you begin the book, right, with these tools, and can you kind of unpack what the relationship is between metaphysics and natural science?
So I begin with these tools. Well, just to give an idea of the methods that you're going to use, so give an understanding of what probability is, which is going to become very important later in the book, what the scientific method is, for example, which again, I'm going to be referring to later in the book. So I needed to introduce these at some point. It seems natural to do them right at the start. As far as metaphysics is concerned, well, the word, of course, literally means beyond physics. So what's meant by beyond here is perhaps a little bit unclear. I think I've heard that it was just the next topic along when Aristotle's lectures were arranged in sequence. But it does also mean something which is more fundamental than physics, which I think is quite apt. So the standard philosopher's definition is that physics is the study of individual beings and the way they interact with other individual beings, while metaphysics is the study of being in itself. So it talks about generalities and what everything has in common. And that's the standard philosophical view, which you'll find in all the textbooks on specifically metaphysics. So my own approach is obviously a little bit different. I'm coming down from the other direction. I'm coming down from the direction of a physicist. And a major goal of contemporary physics to uncover what the laws of nature are. So explain everything around us in terms of some simple principles. But what we can't do as physicists explain why it's those particular principles, or why we want to link, how we can link those principles to other fields of study, such as ethics or religion, and so on. And to my mind, that is the goal of metaphysics, to sort of sit between the raw logic and the applied things such as physics or ethics or religion. So experimental physics gives us the basic data, then theoretical physics explains that data in terms of some model, and then metaphysics explains those models in terms of possibly the most general principles of all. So it explains why the universe has the symmetries that it does, why it has the quantum, why it's governed by the laws of quantum physics rather than classical physics, for example. And all of these in principle should come out of metaphysics.
Yeah, I've noticed that I think I saw a study somewhere that said that theoretical physicists tend to be more religious or something along those lines. And I was going to ask you, with your background in physics, did it make it difficult to approach metaphysics and understand, what authors like St. Thomas Aquinas were saying, Aristotle, or did you feel like you were well acquainted or you had the sufficient background knowledge?
Well, I wouldn't say that my study in physics as such gave me the background knowledge, because they're different topics, they use different tools. So physics, for example, theoretical physics in particular, is extremely mathematical. Everything is expressed in terms of mathematics. When you go to particularly the Aristotelian tradition, there's no mathematics whatsoever. It's all logic, and particularly traditional logic, syllogisms and like. So it's very different way of working. So, and secondly, of course, all the concepts of Aristotle's metaphysics, where if you think about classical physics and Newtonian physics, you don't really use the same concept as we used in Aristotle's physics. I mean, my argument is when we go to quantum physics, they start to be reintroduced. But again, it's a different way of thinking about things. So it does take some effort, particularly since I'm not formally trained in that. I didn't take any philosophy at university. I sort of wish I'd had now, but now I've got into all this. So yes, it took me some time to pick it up, but fortunate for a number of very good resources out there, which are very helpful.
So moving on then to Aristotelian physics, I noticed that you, in the book, you talk about the successes and the failures of Aristotelian physics. So what are these successes and what are these failures, to be very specific?
Yes, well, first of all, I should say that Aristotle was wrong about his physics. That I think needs to be said, first of all, before anybody says that I'm going back 700 years. Physics, ignoring everything that's happened since then. No. But then, of course, so was Newton. Newton was also wrong about his physics. So the question is not so much whether he got it right or wrong, but whether he was taking a step moving us in the right direction. So with regards to Aristotle's successes, I think most importantly, he was probably the first person to give a really systematic and logical and unified understanding of the natural world in terms of natural causes, and one that worked well enough for practical use. So he was one of the first people to take a systematic study of logic, for example. And his whole system is very unified and harmonious. He was also one of the first people studying what we now call science, who looked at experiment and observation as being key to understanding it. This was perhaps particularly clear in his biological studies, but I think it also applied to his physics as well. We don't see many of the details, but he must have looked at it experimentally. So as far as his actual physics is concerned, well, he gives a decent account of kinematics and relative motion. He reasonably accurately describes motion in a fluid or a gas, which is, of course, the circumstances we find ourselves in. So people complain about him that he didn't predict the view of inertia, but of course we don't actually observe inertia. When we throw something across the room, it gradually slows down and comes to a state of rest, which is exactly what Aristotle predicted. As far as astronomy is concerned, he said that the planets were in, well, he said circular orbits, which is not quite right, but he still said they're in orbits, admittedly said around the Earth rather than the Sun, but, well, you can't have everything. And his model was obviously later refined by Ptolemy, if I can say his name, who made it into a very successful very successful model that it took the telescope to disprove and move on to Kepler, for example, Kepler's model of the solar system. Well, of course, there are a lot of failures, scientific ones. Well, his astronomy wasn't perfect, as I mentioned, pendulums, projectiles. Once you go down to the details, his description of these aren't really correct. And that's really what started the medieval scientists to move away from his physics, that he'd got these wrong. Magnetism is perhaps another phenomena which can't well be explained. So all of these became apparent in the later Middle Ages, and then people tried to amend the physics and replace it. But perhaps more fundamentally, well, people often say that his followers put too much faith in reason rather than observation. That's not entirely true, but there is an element of truth in that, which is a major problem. I mean, by the Middle Ages, there was a experimental tradition alongside the Aristotelian one and the mathematical tradition. Then his physics was drawn from two sources. First of all, his philosophy, which is what I'm going to try to defend in my book, but also some concepts such as his four elements theory, which were taken from his predecessors, which it's just wrong. This idea of the four elements theory, which is central to his nature of how things are. So, but his biggest weakness, I think, was that he didn't understand the importance of mathematics in understanding the physical world. Admittedly, he's got an excuse. In his day, mathematics is not very advanced. It doesn't really have the tools that he needs. But starting from about the 14th century and culminating in people like Galileo, it became increasingly clear that we do need to use mathematics to describe the physical world or represent it. And it was only when people did that that we started to notice these problems in Aristotle's physics and were able to move on to the next stage, which is classical mechanics.
So then I guess we can move on to the next question then. So how did, as you call it, the modern worldview arise, and what is it precisely? You know, and I like how when you talk about classical physics, you specifically explore the philosophy of it. And that's something that I think is overlooked because people want to pretend as if the classical picture was just, you know, mathematical, empirical. Philosophy was kind of banished almost, but you notice that there is a core philosophy maybe hidden in there. So could you talk to us about that modern worldview?
Yes, so the philosophy is, I think, very important in the emergence of classical physics, as it was with the theory of relativity a bit later. So as I said, in the late Middle Ages, I mean, most people start with, say, Copernicus or Galileo, but there's some more recent work on the history of science, which points us back a little bit earlier to about the 13th century or 14th century. So in the late Middle Ages, you've got these four traditions which are living alongside each other. So you've got the old Aristotle's idea, which you've been talking about. Then you've got the mathematical physics, which is growing rapidly from about the 14th century. Then you've got the experimental school, which has been going along in the background all this time. And then you've got great technological improvement as well, and in particular clockwork mechanisms. So people can see these great gears and so on moving, and pendulums moving the clock, keeping in time. And actually one of these early mathematicians commented that the notion of the heavens was similar to a great clock in its regularity and how everything was predictable and so on. So it operated like a great machine, as it were, or one of these machines of the era. So if we skip forward a couple of centuries to get to people like Galileo and Descartes, and they took all these earlier ideas and mixed them together to give a basis of what we think of as classical mechanics. So they saw the universe as having mathematical certainty and precision. I should also mention the role of God in philosophy of physics and discuss a few alternative views. So Aristotle and the Neoplatonists in general recognized their philosophy implied the existence of a single first mover or a single source of unity that underlay everything. And that's why the Neoplatonic tradition, Plato, Aristotle, and others descended from Plato, became adopted by Jews, Christians, and then later Muslims. So the God of the Bible, though, is more than just a first mover. He actively sustains and upholds the universe and is involved in everything. So there's a compromise position between deism, where you've only got natural causes, and occasionalism, where you've only got divine causes, which is the theistic position, where they're both natural and divine causes. So these early modern scientists then took a step back from that and believed that the universe could be mapped out according to mathematical trajectories, where the only inputs into the equations are the location and locomotion of matter. So they saw God as a divine lawmaker governing over the universe, which implies the existence of laws governing the motion of matter. So from this we get the beginnings of a philosophy of physics. So every physical event can be explained in terms of the twin principles of matter and motion. All compound objects can be reduced to just the sum of their parts. So just like a mechanical clock can be reduced to its various gears and pendulums and so on, moving in a natural and regular way. The fundamental constituents of matter, which were called atoms then, they're not of what you think of as atoms today. They're indestructible, can't be either created or destroyed. So you can only destroy a compound being by rearranging the parts. And that was viewed as being sufficient to explain everything around us. The laws are designed by God, but they operate independently of God. So God might be needed to give the universe a quick push every now and then. These early people said, obviously, later on, people found there's less and less need for God to push the system as physics grew more advanced. And of course, the laws inherit from God's various properties, such as being unchanging in time or space, being internal, omnipresent, outside the material universe, universally applicable. There's no distinction between the laws governing the earth and the heavens. Then the laws are deterministic. That is to say, if you know everything about the universe at the present moment of time and the location and motion of all the matter, then you can predict what it's going to be like at every other moment of time. Of course, in principle, so in practice, we can't know everything that well. But in principle, if you did know everything that well, you could do those predictions if it's deterministic. And also the laws can be described using mathematical formulae and trajectories worked out by mathematics. So those last points are all linked together, and all of this are linked together. So if you take the independence of laws from God and rationality of the universe, then you pretty much end up with a deterministic universe, as I've described it. So obviously this supports deism rather than theism, and as gods became more and more redundant, people asked, why do we need gods in this picture at all? And that leads to either agnosticism or atheism. So that's very much, there's a trajectory in the philosophy from those early modern philosophers down to the atheism that dominated at the start of the 20th century. I should add, of course, before I finish, that most of the premises of this philosophy have been shown to be wrong.
Yep.
I think only mathematics the universe can be described mathematically, that survives very much so. Many people, of course, would still say that the universe operates independently of God. I personally wouldn't, but many people still say that. But I don't think there's any controversy that all the other premises I listed are incorrect and wrong.
Could you talk about how the quantum revolution kind of debunked a lot of those, central tenets of the classical worldview, or the modern view, I should say?
Yes. So let's talk about, for example, determinism first. That's probably the most obvious. In quantum physics, we see that there is spontaneous decay. A radioactive particle is the best known example. There's no event or nothing physical causing it to suddenly decay. Uranium split into, for example, an alpha particle and thorium. That just happened. There's a certain probability to happen within a certain time. You can talk about probabilities, but there's no event sparking it. So determinism goes out the window. Then a bit more complicated, I said that everything was just the sum of its parts. Well, that's not quite true in quantum physics. I mean, this is a bit harder to describe and explain without going too much.
Go ahead. I'm excited.
Detail. But basically in physics, when we go to a compound of objects, we use something called effective field theory. So we start with the most basic constituents of matters, such as quarks and gluons and photons and electrons and so on. And then you can put these together. Well, you can study these interactions between these particles in terms of various operators which describe them. And then you can go to the next level up, which is protons and neutrons and pions and so on. And you also can use the same mathematical framework to get these protons, neutrons, and pions, but you do so via transformation of the operators for quarks, electrons, and gluons, which isn't just linear, isn't just putting them all together, but it mixes them all together in some way. So in such a way that it's not just, you can't just call a quark, a proton, for example, 3 quarks and a bunch of gluons. I mean, for example, the quarks have mass of about 3 megaelectron volts up to about 10 megaelectron volts. A proton has a mass of about 940. I'm sorry, the megaelectron volt is a unit of mass that physicists love to use because it's nice and convenient for this sort of particle. If I should be talking about 10 to the minus 31 kilograms or something, it's much easier to talk about MeV and keep right between 10 to the minus 31. So in any case, the proton's mass is much bigger than, say, 3 quarks, and the gluons are massless. So obviously there's something else going on here, and it's just 3 quarks happen to be stuck together. So is there just matter and motion? I said that. Well, no, there are numerous other things. In particular, we talk about energy bands, which don't really correspond to something moving as we think of motion in classical physics. So again, that's a very different way of thinking about it in quantum physics as compared to classical physics. I'd say the laws inherit these various properties, such as being eternal and omnipresent. From that we get various symmetry principles. That still stands, but whether they operate independently of God, well, that's what I'm disputing. Or I mentioned indestructibility as well. The fundamental constituents of matter indestructible? No. We find that particles decay. So, for example, electron comes on, a photon is emitted from it. The photon changes into electron-positron pair. We've had 1 particle, now have 3. And that's observed all the time in particle accelerators. So hopefully that's most of the premises that I listed, have just discussed, and shown why they don't work in quantum physics.
Yeah, that's totally fine. So I'm now really excited for this question. So in light of contemporary developments in physics, how viable is Aristotelian metaphysics? So this is a big question. Right? This is almost like, the main thesis of the book. So take it away. Yes, I'm excited.
So having written my book basically about this, obviously I would say it is very viable. To an extent. I mean, it needs some modification, it needs adjustments. We've had 700 years of physics, development in physics. Obviously, that's going to change some things. But the basic picture, so I'd say that we should, Aristotle's metaphysics is a good starting point. It's not where we should finish, but it is a very good starting point, and it's something we can build on, whereas the more modern worldview, the mechanism I just described, doesn't really work at all. It's basically a non-starter. So it would take me a long time to go into details, both in terms of the philosophy of physics. So I'm just going to be able to give a very brief outline and hope people can vaguely understand what I'm going to say. So when I think about what's distinctive about Aristotle's metaphysics, the first things that come to my mind are the theory of act and potency and the fourfold theory of causality. So potency is how Aristotle explains change. Basically, it's the middle ground between existence and not existing. So it represents the capacity to change. For example, a child is potentially an adult. So that means if you put the child in the right circumstances, then there's a chance that he will change into an adult. I mean, and naturally would change into an adult unless you kill him or somehow stunt his growth and become an adult. But both the child and the adult refer to the same individual. So we can think of this in terms of states. So we can think of a person existing in a number of states. So one of these states refers to the child, another one refers to the adult, and changes when you move from one state to another. So the adult doesn't not exist when the child's alive, because he's the same individual as the child. So in some sense, he's existing, but obviously he's not here right now. So we say that he has potential existence within the child. Okay, so it's a third category alongside non-existence and existence. You have potential existence. So this language of states and changes and movements from one state to another is very, it's used everywhere in quantum physics. Once you get past the basic notion of Schrödinger's equation and a wave function, then, and you go to slightly more advanced notation, then everything is described in terms of states, expressed in various different ways. So it's very natural to quantum physics. For example, you can consider the hydrogen atom, which is very well understood in quantum physics. It resembles a heavy proton at the center and a light electron around it, but the electron is constrained to be one of a discrete set of energy states. So you can move it from one state to another. For example, we can go from the 2s state, which is the first excited state, down to the 1s state. And it has the potential to drop down to the 1s state. So that if you put the hydrogen atom in the right circumstances in the 2s state, then there's a chance that it will transition to the 1s state. So it's the same hydrogen atom in both cases, but clearly there's a distinction between the states. So when it's in the 2s state, we can again say that the 1s state exists potentially. So clearly there's a very clear analog between those two processes, one taken from the classical examples, the other from quantum physics. It's a different example, but it's the same underlying way of looking at the world.
If you don't mind if I just ask a question. So with the different states that things can exist in, right? For Aristotle, he divides being into act and being into potency. So when we talk about these quantum states, are they also real in some sense? They're not just illusory or just mathematical abstractions. They are in some sense real.
Well, it depends what precisely you mean by real.
Yeah.
But I'd say that most of his quantum states are potential. Mm-hmm. So there's a little bit of complication here because there's something called the principle of superposition. But in general, we can say that something is actually in one state, which might be a superposition of various states, but it's actually in one state and then potentially in various other things. So when we measure a particle, we always find it is in one particular state. And at that point, we can say, yes, that state is actual. Between measurements, of course, we don't know precisely what state it is. And there's a big debate in the philosophy of physics about whether that's don't know is just a matter of our knowledge, our not knowing, or real and fundamental. feature of the world. I tend to think it's more of a matter of our knowledge than a real and fundamental feature, but that's, say, one big debate into the philosophy of quantum physics, which I've found myself wading into with all this work. So yes, I would say we can say there's a state which is actual, and then various other states which exist potentially, or potential, but they're just as real as the actual state. Or they're not just as real as the actual states, but they're not real.
Yeah, they're not real.
Yes, they're not real, even if they're not real in the same sense that, say, this chair I'm sitting on right now is real.
So then you were going to talk about Aristotle's four causes, or Aristotle's conception of causation, but is there anything you wanted to say about this section again about act and potency?
No, I think I've said pretty much all I can say on that, which at least at a relatively simple level. Yes, again. Okay, so for four causes. So these are the formal cause, the material cause, the efficient cause, and the final cause. So the formal cause in some way represents the way something is put together. So unlike Plato, who said that, and it also, in some way determines what something is. So for example, a cat has one particular form, a dog has another particular form, and the differences between cats and dogs are because they have these different forms or natures. So Plato had forms existing in their own right in some sort of abstract space, but Aristotle said instead that the forms are inherent within different natures. So a form would include a description of all the different states that I've just been discussing. It's basically that part of a being which we can represent abstractly. Then you've got the material cause, which represents the matter, or basically what makes a being or a substance not just an abstract concept. So this chair I'm sitting on, I mean, it has all the appearance of not just being something abstract. So you can still think of some abstract properties about it, its shape and so on. But it's also something concrete really there, or at least it gives all the appearance of that anyway, and consistent with that. So the form matter distinction is also linked to the act potency distinction. So matter is traditionally thought of as being, or prime matter, or pure matter without any form, is thought of being pure potency, because it can take any shape. It can be basically merged into anything, at least in Aristotle's philosophy, whereas a form basically comes in and forces it into one particular type of being. So form describes the set of states. So it's not just fixed. It's not just one fixed thing, but it can allow for variation. So if we look at the way form is used in classical philosophy, we see in quantum physics, the operator that's used to define the states takes on a similar role and plays a similar thing, particularly when we move to composite beings. So we get distinct states, we get properties of a being, we get how it changes and how it interacts with things. And all of these are what is said about the form in classical philosophy. So again, we've got a clear correspondence between the classical form and the quantum operators that are used to, or mathematical operators that are used to describe matter. Then, of course, we've got efficient and final causality. Efficient causality is probably closest to what people today think of in terms of cause. But there's an important distinction which I don't see discussed, I think, as much as it should do, between what I call event causality and substance causality. So in event causality, the cause of being is an event. And then you can talk about the cause of event in terms of a particular combination or conjunction of substances. In substance causality, you go from one substance to another substance directly, and you sort of skip over any event in the middle. And efficient causality and final causality, as we read it in Aristotle, link one substance with another substance. So the efficient cause is basically saying, or actually I should say one state in terms of another state, rather than talking about substances. Substances are basically the union of form and matter. They exist in numerous different states. So you can say, what is the efficient cause of this state, and the words of being in another state. So if the efficient cause asked, where did it come from? The final cause asked, what states can emerge from this, or how can this decay? So in terms of physics, we talk about decay channels. So we talk about a particle which can decay to numerous other different particles. And this is almost exactly the same thing as I've just described by final causality. It's a tendency towards certain effects, but not others. And the efficient cause, well, once again, in the more advanced quantum physics, when we combine it with relativity, we get to the conservation of momentum dropping out. And that means that you never have something emerging from nothing. Whenever something emerges, there's always something preceding it. So you can map out what precedes it, and that gives you the change of efficient causes. And this idea of efficient and final causality is basically the minimum you need to be able to think about a rational universe and natural causes, and to be able to do science. So I could go into far more detail, just talk about other things as well, but I've probably said enough on this question. That just gives you a flavor of the correspondence between Aristotle's metaphysics and contemporary physics.
Yeah, I mean, even going back to the act potency distinction, right? The potencies are for certain end states to obtain. So there's already something teleological in character. I'm interested. Yes. Are there more examples of teleology in quantum theory?
More examples? Well, this is not really quantum theory, but you can talk about Phoneme Dynamics, for example, which basically means that everything has the tendency towards an equilibrium state. Mm-hmm. So if you piled all the gas molecules in one corner of a room, they would have a tendency to spread out and fill the room, where it's just as likely that, for example, two gas molecules swap around. That's not really quantum physics, it's in classical physics as well. Or, for example, the sun is gradually dying. We know that it's losing energy. Eventually, it will burn up the last of its hydrogen, burn up the last of its helium, and would stop producing energy. It's running down to an equilibrium state, which just collapse into a dwarf star of some description, probably if it was bigger as black hole. So there's this tendency towards an equilibrium, which is another example of a tendency towards an end or final causality in contemporary physics. I've mentioned decay channels for radioactive decay. There's another example. I mentioned the hydrogen atom, a state going down from an excited state to the ground state. The electron, that's another example of final causality, tests the natural tendency to do that. Or even quarks and gluons have a tendency to form up and form a proton. So again, another natural tendency.
Yeah. So, and the point here is, this is more nuanced than, let's say, something like, I don't know, like when we talk about teleology, some people think like, oh, you think, like God is a watchmaker who kind of imposed order, right? But what we're saying with teleology is something intrinsic to the things themselves, right?
Yes, it's something intrinsic. So there's a lot of confusion between teleology and design.
Yeah.
So design being the watchmaker. Arguments from design are actually a bit later than this. They emerged around the same time as classical physics emerged, and particularly see them in, I don't know, the 17th century, I think. You see people like Paley, I think it was 17th century. Anyway, CP and 18th century Hume, obviously, rebutting them. So there's a big difference between design and these two things. So design depends on complexity and parts joined together, whereas final causality refers to even the simplest substances. I mean, you don't get much simpler than a hydrogen atom. And I've said there's a tendency in there for electrons to drop down into the ground state, for example, which is an example of final causality. So design and final causality are very different, as you said.
All right. One of my friends who actually, excuse me, who actually has studied physics, and I think he's read your whole book. He just had a few questions. So don't worry, I hope they're not too crazy, right? So one of the questions that he asked was about the holographic universe and how it relates to quantum theory. And he also wanted to know what your interpretation of, I think, quantum mechanics is.
Okay, so the first question, holographic universe. It's not something I know a great deal about, unfortunately. So I'm afraid I can't really answer that question without doing a bit of research. So
Yeah, okay.
so sorry to disappoint you there. um, so my interpretation, I prefer to say it's interpretation of quantum physics rather than quantum mechanics.
Yeah.
Because in quantum physics, we had two stages. First of all, there was what I call quantum mechanics proper, which was the theory of the 1920s and 1930s, which was inconsistent with relativity. And second, then we've got quantum field theory, which is what you get when you merge quantum mechanics with relativity. And quantum field theory is similar in many respects to quantum mechanics, but also has a few differences. And the most important differences come from the equation E equals mc squared, which states that energy and mass are convertible, or you can create, in principle, turn kinetic energy into mass and create new particles. So in quantum field theory, the fundamental operators are what's known as creation and annihilation operators, which create and annihilate new particles. So, and what we see is, for example, we can do one way of solving quantum field theory is to use perturbation theory, and there we actually draw diagrams of paths or possible paths of particles, which can showing an electron coming on from a wiggly line representing a photon, and then a couple of other straight lines representing the electron positron. This straight line at the bottom continues. That's what's known as a Phoneme diagram. Sorry, I strung it to my finger. But there you see an electron emitting a photon, becoming a electron positron pair. And we can't take the Feynman diagram picture literally because the various problems such as what to make of a quantum vacuum, there's something called renormalization, which is important. So these things represented of this diagram aren't actually the physical electron and photon. So there's some complications, but this broad picture is what I use as the basis of my philosophy. So we have the idea of efficient causes coming along, particles being created out of them, and so on. The only thing is that this system is indeterminate. So you can say what the initial state is, but you can't say how it will develop until you measure it. So effectively what you have to do is build up every possible option from the initial state to work out the probability of the amplitude of your final state, work out every possible option, and then add them together to make up the final state. So my philosophy of quantum mechanics or quantum physics, there's more to it than this. You also have to talk about entanglement, which I don't want to go into here, which is the other key thing, and the two-slit experiment. I mean, these are the two, I just think, most fundamental experiments of quantum physics. But it's basically based on this idea of particles creating other particles, particles emitting them, decaying, and so on, this chain of efficient and final causes. But the system is indeterminate, so we can't make predictions. We have to consider every possibility. We have to work out amplitudes for each possibility, add them all together, and the end to work out a probability for each possible final cause. So it's a combination between Aristotle's philosophy and indeterminacy at its root, at its heart.
And just to go back to the Aristotelian metaphysics question really quick, some people have wanted to refer to, I think, the wave function as being analogous to prime matter in Aristotle's philosophy, or at least like as you get to the more kind of bottom levels of reality, let's say, like, you know, things become more abstract and, you know, you have to, you have to have collapse, right, in order to have concrete objects or more organization. Some people would refer to that as being like getting closer to prime matter when you get to the more abstract level of reality at the bottom. Would that be another analog, or?
Yes, I think Wolfgang Smith has particularly been talking about this, and there's a I mean, sense imagery goes back to Heisenberg, this idea. I mean, it depends in part on your understanding of your philosophy of quantum physics. So you're talking about the collapse of a wave function.
Yeah.
That's due to something called the Copenhagen interpretation, which is sort of a default one that most physicists follow, but not wholly accepted in there are other alternatives to it. But yes, that's one thing you can think about. I would probably more say that once again, I'll go forward into quantum field theory. So here we've got fields which basically extend across all space. And then you can think of about little lumps in those fields as being the particles. So I generally use a particle, think about this in terms of particle interactions rather than fields picture. But I would say these fields more represent prime matter.
I see. Okay.
So mathematically, they're similar to the wave function. So the wave function in quantum mechanics becomes a field in quantum field theory, effectively. So yes, I mean, there's something similar there, but I think it gets a little bit more complex when we go into field theory.
All right. So to the next question, I know. So every single time I've talked to anyone who's a Thomist philosopher of mind or physicist or in these fields, they've always asked. A lot of my friends have wanted me to ask about whether or not hylomorphism, basically Aristotle's philosophy, his metaphysics, can be combined with idealism. And I wanted to ask you then. So, what would a quantum Thomist have to say about the nature of matter? And do you think it's possible to marry idealism and hylomorphism together?
So the first question we have to ask is what's meant by idealism here, because there are numerous different types
Yeah.
of idealism out there. So I think they've all got in common the idea that reality is some way dependent upon the mind, which, whether that's a human mind or perhaps the mind of God. So, for example, you've got subjective idealism, which states that everything around us is just basically a figment of our own thinking and our own imagination. It's more complex than that, obviously, but more simply. Or you've got objective idealism, which states that everything is part of the mind of God, or Kant's view, which is a bit different and makes a sharp distinction between the world of perception and the world that are things in themselves, of the world that really is. So, so when we engage in science and Kant's view, we look at the world of perception. So the world's basically in our minds, that's what we model, whereas the world of things in themselves is not really what we model or understand. So hylomorphism is what I was discussing, that matter is the union between form and matter, or substance is the union between form and matter. So we've got these two components to everything. The form can be represented as an abstraction. Abstractions are things that can be understood in the mind. So, and that abstract layer is crucial to any substance. You can't have a substance without this layer of form. So there is certainly a similarity with idealism in that there is this abstract layer to the universe, as opposed to materialist view, which states that everything can be described in terms of matter alone. But there are also some differences between hylomorphism and idealism. In particular, I'd say that in hylomorphism, the form is internal to the substance, whereas in idealism, we think of it being something external, so it resides in an external mind. The other more obvious one is in hylomorphism, you've got matter, which in idealism, you don't, or at least not in the same way. Maybe Kant does, but Kant's philosophy is certainly different. So it has a mind. A matter is something that cannot be exist within a mind. It basically is not something we can grasp or think about. We can understand the structure, the form of a being, but not its matter. So I would say that I wouldn't say that hylomorphism and idealism are compatible with each other. There's some similarities, certainly. They're possibly closer than hylomorphism and materialism, but there's still differences. Hylomorphism is something of a middle ground between idealism and materialism.
All right, going on to the next question now. So I noticed in your book, you also, I mean, the subtitle of it is A Defense of Classical Theism. So which of the classical arguments for the existence of God do you find most convincing, and why? So we'll start with that. There's a second part, but let's just hit the first part.
Okay, so the least convincing argument I'll begin with, and that's easy, the ontological argument. I've never, I mean, with all due respect to Alvin Plantinga, I've never really been happy with the ontological argument. I found it convincing, and mainly because it starts with a definition of God as the greatest conceivable being. But then you have to ask about what is meant by greatest. And in particular, you usually think of greatness in terms of the nature of a being. So being achieving what its maximum state of goodness. Well, goodness again depends on what the final causes or purpose of a being are. So that strikes me as being some circularity in that definition. So I wouldn't deny that God is the greatest conceivable being. I just think you need to have a definition of God and a definition of greatness, or an independent definition of greatness, before you can actually come to that conclusion. So then obviously the other classical arguments are the cosmological argument, the teleological argument. There's also Aquinas' fourth way, which is a little bit different. I don't really make use of it myself. This is the argument from degrees, or from the transcendentals in particular. So it's particular types of properties such as goodness or being. So we can distinguish degrees of goodness by comparison against a maximum good. So that the argument goes, which implies there's a maximum good, which is a being which can't change. Obviously, if it changes, it would no longer be, it would change from being perfectly good, so it become imperfect. So these graduations point to a being of pure actuality, which is identified with God. Now, I haven't expressed this particularly well. It's not something which interacts with science. So it's not, I'm not the person to defend it. I think it can be defended, but it strikes me, my own view, which is prejudiced, is that it's probably the weakest of Aquinas' five ways. But that might just be my prejudices coming from the angle of a physicist, and that I don't fully understand or appreciate the philosophy behind it. So then we've got the first three ways of a cosmological argument, which is well known and probably the most famous argument for God's existence. So in brief form, it goes, I'm sure most of the people looking here are familiar with it, but in brief form, it goes, some things have a cause. This cause must itself either have a cause or be uncaused. That chain can either continue forever or must terminate with an uncaused being, but it can't continue forever because it is an instrumental series of causes. So the effects can only exist if its cause exists, which can only exist in terms of its cause exists. So if a sequence continues to infinity, then whatever passed is passed down this chain of causes, doesn't have an explanation. So the classic example is a stick pushing a stone, pushing a stone, pushing a stone, and pushing a stone, and so on. So if you see a line of stones moving along the ground, going beyond what you can see, going beyond the horizon, you just see this line of stones moving along the ground, you can naturally think that there must be something pushing them or pulling them, because stones naturally don't move that way. And they also have a natural disposition as to be at rest. So if they're moving, there must be something pushing them. And the same thing is applied to the cosmological argument for chain of causes. There's something being pushed down the chain of causes, which naturally you wouldn't expect to be there. It can't be explained in terms of these beings themselves. So you have to say there's something outside it, different from the sort of things we usually see around us, which initially supplies that thing which is being pushed along the chain. So an infinite chain is impossible. So then you can conclude there exists a being which is uncaused, doesn't have a cause. And this only makes sense. Otherwise, you can ask what caused this uncaused being. It only makes sense if this being has cannot in principle, given its nature, be caused. So it's a necessary being. That implies it's unchanging. That implies there's no potency in it. So it's immutable. It leads to divine simplicity, divine, which means that God is not composed of parts. That implies the unity of this. So that implies that God is the head of every chain of causality, which leads to omnipotence. Everything material is composed of parts, not least form and matter, if you accept Aristotle's philosophy, and it's subject to change. So God is immaterial. So he's outside. If he's immaterial, everything material is in space and time, or everything in space and time is material. So God is outside of space and time. He's able to effect change in others. The only immaterial thing capable of doing that is the mind. So we have a immaterial, omnipresent, omniscient, omnipresent, timeless, unchanging, and unified mind, which I think most people are happy to call God. So obviously, I've just skipped through that very quickly. There's you need more detail. I don't expect anyone to accept what I've just said, but that detail exists in pretty much any book that discusses the cosmological arguments by a classical theist. So that's, roughly speaking, the cosmological argument. And Aristotle's first three ways are variations of that. So they just differ in the type of cause that they refer to. So the first ray is the argument for motion. So it talks about motion. The second ray is efficient causality, which is closest to what I just described. And then the third ray is the argument from contingency and necessity. And it's actually that third ray which I like the most. It's just neat. I think the one possible weakness with the cosmological argument is this argument about whether it is a instrumental chain of causes, which needs to have a first mover, or an accidental chain, which doesn't. I think that needs to be proved, and you need to do some work to show that it's a instrumental series. But I think in the terms of third ray, that drops out very easily. The second ray I like quite a lot as well. The first ray gets a bit more interesting, because here we're talking about the notion is whether every motion requires something to move it. And obviously, when we come to quantum physics, we're starting to think about spontaneous decay here. They're also objecting classical physics, the principle of inertia, and so on. But we shouldn't forget that what Aristotle meant by motion was different from what a classical physicist meant by motion. And once we sort out that, then these problems based on inertia and so on disappear. But spontaneous decay seems to be something that changes without something changing it, or something physical changing it, which leaves us with two options: that it's something non-physical, something supernatural affecting this change, or there is a break in the rationality of the universe, a break in the chain of premise to conclusion. So I think this argument, the first ray, it either gets you very directly to God, or you've got a bit more work to do to deal with these spontaneous events and spontaneous decays. Sorry. Then you've got the fifth ray of Aquinas, this ray, which is the teleological argument, of the arguments from final causality. In my view, this is also very strong. It's not the argument from design. So most people today, they confuse the two. They just discuss the argument from design, which talks about the arrangement of parts. So this asks how an inanimate object could choose what end to aim at unless it's directed by an external mind. And by considering the nature of that external mind, we also come to God. So again, I think I haven't gone into detail. I can't hear, but that's also a pretty strong argument, I think.
All right. So I think I'm going to skip the next question. The next question it basically just has to do with what you've already stated. There's a little bit about Kant and Hume in the next question, but I feel like I'm more interested in getting to the last three, if you don't mind.
Okay, fine.
All right. So, I've heard some people, in the book, right, you specifically lay out the attributes of God, and you include, how important simplicity is to this vision, right? That God is not composed of parts, and there's no like composition in God, basically. So there have been arguments, right, that God cannot be simple, timeless, immutable, or impassible. And, this has even come out of other theists, right, who believe that there's something wrong with this classical model of God. I wanted to ask you, have you encountered these sorts of arguments, and what do you make of them?
So have I encountered these arguments? Well, again, I'm not a theologian, so I probably haven't encountered all of them, but I have encountered many of these arguments. What I think of them, right? I don't think any of them are strong enough to refute the arguments in favor of simplicity and God's timeless nature. I should say these things that you mention are all linked together. So, for example, simple, one aspect of this is you're not composed of acting potency. So therefore you can't change, and that implies immutability. Being timeless is again, time and change are related to each other. So change is, so if you're timeless, again, this implies you can't change. So therefore, immutability. So since we don't have so much time, I was just planning to focus on the two most important, I think, which are being timeless and being simple. So first of all, what does saying God is timeless actually mean? Well, it means that God does not experience any one moment of time as the present, but relates to all of them together rather than being in succession. So that's very different from how we experience time. So we see one moment of time, then another, then another, and then another, and we only experience one of them at once. But the idea is God basically sees everything in one go, as it were. I mean, it's difficult to get your mind around because obviously it's completely alien to how we view the world and how we think about the world. So the philosophy of time is disputed, I should say. There are numerous different views. There are various questions we can ask. For example, is succession in direction and time objective truth, or are they just subjective, something we perceive but not actually, but only a matter of our own perception? Or are the past and future objectively real in the same sense that the present is real? So many classical theists would say that the past and future aren't real in the same sense that the present is real. This leads to a view called presentism, which is sort of a default position of classical theists. I actually take a different option. I think relativity clearly implies that there is a reality in the past and the future. Then you've got the notion of whether you can single out one moment of time as the present. Is that just subjective, internal to ourselves, or is it objective? So in principle, every person existing at the time would agree that, yes, that moment is the present, that's the past, that's the future. So my own answer to these questions is that there's an objective succession. One thing comes after another thing. There are few complications with regards to place, but in general, succession and the direction of time is the same throughout the universe. The past and the future are real. The awareness of the present is subjective. And I'll be coming back to that in a moment. So a couple of arguments for divine timelessness. This one I took from William Lane Craig, who's one of those theologians you mentioned. He's a very prominent apologist and brilliant debater. So he argued as follows: 1, God is creatively active in the temporal world. 2, if God is creatively active in the temporal world, then God is really related to it. 3, if God is really related to the temporal world, then he is temporal, and 4, therefore God is not timeless. So one question here is what he meant by really related. And it wasn't actually clear from his book, or at least not when I quickly glanced over it again when looking this up. But the commentary around the argument suggests that it's a relationship where both parties are in some way affected by the change that comes, certainly is important to his argument. So it's part of his argument, whether that's premise 2 or premise 3 in the argument, I'm not sure. So the argument runs that in creating the temporal world, God undergoes a change in his relationship to it. and if there's a change, then he must be subject to time. So to quote directly, for the first moment of time, God stands in a new relationship in which he did not stand before, since there was no before. So there's an extrinsic change in God at the moment of creation. So my concern with this is that the word new there, that God stands in a new relationship, smuggles in the notion of temporality into this. So you can only have something new if you've got a past and a future. So it's applying this to God. So it's smuggling in the premise of divine temporality into this argument, which obviously makes the argument circular. Its premises, or its conclusion, is one of the premises, and therefore it's defeated. I could say more, but again, it's not something that I found convincing, and I do think a timeless God can coexist with a temporal world.
Yeah, so you wouldn't say that just because God produces some effect that he has to change with the effect.
No.
Yeah.
So effectively, this was timeless means that God views both the cause and the effect, as it were, together. So just because there's a change in the temporal world, that doesn't mean that God has to change in doing that.
Yeah, I mean, some classical theists would say that God stands in a logical relation to the created order, right? So, for instance, the tree, or let's say the plant in this room, right, is in my intellect, and now it is not, right? It nothing about the plant changes, only its relation to my intellect or my standing with it in some sense, but it doesn't have to change. That's how I've seen some people explain it, the relationship between God and the created order.
Yes, so here the plant would represent God, I guess, and your intellect would represent something temporal. But yes, okay, aside from God is not a plant, then
Yeah.
yeah, very, very different from a plant. Okay, so a second argument about timelessness is to say that 1, a temporal world exists, 2, God is omniscient, 3, if a temporal world exists and God is omniscient, then God knows temporal facts. And 4, if God is timeless, he does not know temporal facts. And then 5, God is not timeless as a conclusion. Oh, sorry, a tensed fact or a temporal fact, I should have said tensed facts, is something like it is now raining, or the Battle of Waterloo was in the past. So it's something that depends on the notion of the present. So the way I would say this fails is that omniscience means that God knows everything that it is logically possible for God to know. So we naturally exclude from this contradictions. I mean, it's not possible to know 2 contradictory statements at once, obviously. We can also exclude from this subjective statements. For example, the statement, I am Peter. It's true if someone called Peter says it, but it's not true if I say it. So it's subjective. And this is all, I mean, it's also not true if God says I'm Peter, if God thinks I'm Peter, obviously that's false, because God is not Peter, whereas Peter can legitimately say that he's Peter. So these subjective statements or subjective knowledge is also excluded from omniscience. And again, I can't really see how people can debate that. So now we come to the philosophy of time, whether the notion of the present is objective or subjective. And what I was suggesting before, and this is the way I always get around this, is that the notion of the present is subjective. So I have my notion of the present. Abraham Lincoln had his own notion of the present, 150 years ago or so now. So he said the present was sometime 150 years ago, as I'm saying it. I'm saying the present is now. We both had our notion of present, but it is subjective, internal to ourselves. And if the notion of a present is subjective, then every tensed fact would also be subjective. So it is now raining. It depends on my subjective notion of time and what's the present, what now means. So therefore, it's not part of omniscience. It's not included in the definition of omniscience. And in that way, you get around the problem, the dilemma of the argument. Okay, so divine simplicity is another thing. So this is the doctrine that God is not composed of separable parts. So one argument against this, which is commonly said, is related to the attributes of God. So divine simplicity also reads as in telling that all these attributes must also be in some way equivalent. So you have something like God is both omniscient and omnipotent. Omniscience is to knowledge what omnipotence is to power. Knowledge and power are different from each other. So omniscience and omnipotence are different, and then there exist differences in God, and God is not simple. The way that classical theists would deal with this is to say that God is fundamentally different from us. So when we talk about power, for example, we mean something different. When we talk about power within us and power within God, we're actually talking about two different things. There's a similarity there. The meaning is analogous. As you say, there's an analogy between the two meanings, but they're different. And the same thing is, for example, when we talk about knowledge, when we talk about own knowledge, God's means of knowledge are very different from our own. We can't really equate God's knowledge with our knowledge. It's not just God is like us, but just knows a lot more. It's God's knowledge is fundamentally different from what we know. But God's power is fundamentally different from what we call power ourselves. So you can't say that knowledge and power, because they're different in us, you can't say that they are different in God, but rather you would say that they are two different aspects, as it were, of the same thing. So both of them get derived from the logically derived from the endpoint of the cosmological argument. In some respects, they are equivalent to each other. Okay, there's a distinction we can talk about. Some distinction, but functionally, as far as God's concerned, they're basically equivalent. One of them implies the other one, the other implies the first one. They're not separable. You can't separate them. So we say this doesn't imply parts within God, simply because of the knowledge and power difference in God compared to us. So the second objection is related to the Trinity. I've also seen this one quite a lot. So it says Father, Son, and Holy Ghost, or Holy Spirit. There immediately you've got a difference, and God has parts. And what I'd say here is that the Trinity was formalized in the 3rd, 4th, and 5th century. The people who did so were Neoplatonists. They believed in divine simplicity. And one of the main problems in formulating the Trinity is how to unify the distinction between Father, Son, and Holy Spirit with God's unity and simplicity. So what we're trying to do is come up with an idea that encompasses both simplicity and unity. Obviously, if we say that the distinction between the three persons is one of the parts, then what we're doing is tending towards tritheism, three gods, which contradicts the unity of God. So the doctrine of the Trinity specifically denies that the Father, Son, and Holy Spirit are parts. It's formulated to do precisely that. So the notion of a Trinity is not an obstacle to divine simplicity.
All right. Do you want to talk more about just because that's actually the next question.
Yes.
About the Trinity itself. So how you articulate it and defend it in your book.
Yes. So we talk about the three persons of God. So a person is defined as an individual element of a rational substance. So for ourselves, for example, the rational substance is mankind, and we are individual elements of it. So each of us is an individual person. So we can think about different ways to distinguish between things. So you could be composed of a different matter. For example, if I had a twin brother, which I don't, but if I had a twin brother, he would have the same form as me, but different matter. But obviously God is not material, so that sort of distinction can't exist within God. Then we have a distinction due to, for example, temporal history. Something my twin brother would have also had different past to me, as it were. But again, it's not applicable to God or me, actually 5 minutes ago. It's different from me now because of this difference in time. But that's God is timeless, not applicable to God as well. Or we might have a distinction in form. So you can have the same matter, but at some point it's changed into something else. For example, diamonds and graphite are made of the same carbon atoms, but arranged in a different way. So they have different forms. But the unity of God implies that that is not applicable to God as well. So God's simplicity rules out a distinction of form. It also rules out, as I said, distinction in parts. And that also implies that God is of one substance, so united in his substance, if we go back to the philosophy. But then we have the distinction in relationship, and in particular, a hierarchical relationship. So the classic example is a father and a son. So there's clearly a distinction between the concept of being a father and a son. You can't just swap them around. Now, this analogy, if you think about a human father and a human son, there are obviously other differences between them. But this is a different sort of distinction that doesn't necessarily relate to the substance. One picture, which I think goes back to Augustine, I first saw it in Augustine, is the distinction between the thinker and the thought. And these aren't separable parts because you can't have a thinker without a thought. Neither are they interchangeable with each other. It's a hierarchical relationship. So if you have a thought, then you must have a thinker, and it exists within every mind. So in some sense, if God is a mind, then there's this distinction between thinker and thought. Now, this is just a picture, obviously, of a Trinity. It's no doubt flawed in various ways because all of our pictures are flawed in certain ways. But the fundamental idea is that the persons of the Trinity are united in their nature and their substance, but they are distinct, and they're not parts, but they're distinct from each other in terms of their relationship. I mean, this is difficult for us to get our heads around because everything we see that is distinct in relationship is also different in some other way as well. But logically, there's no reason why that has to be the case. So we can say that we can have something united in substance, but distinct in terms of relationship. And that, I think, is the classical way of looking at the Trinity.
Right, as processions, right?
Yes.
Yeah. So maybe to be a little controversial, do you believe that the Spirit proceeds from the Father and the Son, or do you believe that the Spirit proceeds directly from the Father?
I'm afraid the church I belong to specifically accepts the Filioque. We're descended from Roman Catholics.
Yeah.
So we accept Filioque. It's not something I am particularly hung up about. So if the Eastern Orthodox turn out to be right, well, okay, fair enough. But yes, I would formally have to accept Filioque if I agree with the adoption of my own church.
Let me add a question in, and then we'll get to the last question, which I'm really interested to see your answer. But obviously, when you accept a classical theist picture of God, you're not going to get clean-cut, clear answers. Not everything is going to be exactly univocal, or just let's say quantifiable in our language, right? There are some things that almost just go beyond description in God, and you can call it kind of Mysterianism maybe at some points. You can't just figure out everything about God. And suppose someone says to you, Nigel, you're a scientist, you know better than this. What would you say in response to someone who would think that you can't have this mysterious view of God, you need something more tangible? Or what makes you willing to say, I accept the mystery, if you will?
Well, I mean, you're certainly right to say that we can't get a complete picture of God. God is fundamentally different from us. He's fundamentally different from every creature. And our minds are thought to think about created things. I mean, we live in a universe where everything is a created thing. So yes, there's this fundamental difference. As a scientist, well, the first thing I'd say is experimental error. So whenever we give an experimental result, we can't say it is exactly this. It always lies between various bounds. So we can try to reduce those bounds, but we can never eliminate them. There is always going to be some uncertainty and imprecision in science. And that goes on to theory as well, because many of our theories, for example, they depend on parameters which we can only measure from experiment. So our theories, again, are only ever going to be imprecise. They might get, hopefully that imprecision reduces over time, but we're never going to get them perfectly precise. So, plus, of course, there are things which are mystery. For example, unifying general relativity with quantum field theory. Sure, I've got ideas about how that should be done, but it's still a big unknown question. It's still a mystery. We might hope to get the answer one day. So I think saying that there's some things which we don't yet know, maybe one day we can figure out, but don't yet know, is very much compatible with working as a scientist. In fact, looking for things we don't yet know is part of a scientist's job. And secondly, think about things as imprecision. So we can't know something perfectly. We can't get everything perfectly narrowed down. Again, a scientist deals with error bounds and so on all the time. So he would be fully comfortable with the idea that we can't get a completely perfect picture of God where everything is worked out. There's going to be some vagueness in there. There's going to be some imprecision. And once again, as a scientist, that's very familiar. It's something I can reasonably understand. We can still narrow down what you mean by God, what you mean by divinely simple, and what you mean by timeless. We can still express that. But there's, as you say, there's imprecision in the definitions, but that's just what we deal with as scientists: experimental uncertainty, theoretical uncertainty. We discuss that sort of thing all the time.
All right, now to my last question. So, do you think quantum physics makes it harder or easier to be a theist, and vice versa? How about the atheist, or specifically the naturalist? Does it make it harder or easier for them to be an atheist or a naturalist?
Okay, well, obviously I have my own view here, which not everybody will agree with. So I'll discuss the atheist first. And does quantum physics make it impossible to be an atheist? Well, obviously there are many people around who are both atheists and have very good knowledge of quantum physics, so you can take from that what you like. What might be said is that they might not be so knowledgeable about philosophy, so they might not have their own worldview perfectly worked out in every detail. People can hold contradictory views at the same time. So it's not a definitive answer to the question. So I'd say atheism is based on the idea that the universe is firstly rational and secondly it's closed. So there's nothing outside it that comes in and intervenes. So these taken together, I'd say, seem to imply a deterministic physics. So the atheist has one big problem, namely that quantum physics is not deterministic. Now, there are various ways around this. So probably the most prominent or popular is Everett's multiverse interpretation of quantum physics. There's another interpretation which is also deterministic, which is the de Broglie bomb planetary theory, but this is generally held to be inconsistent with relativity, so it doesn't get so much discussion. I'm in a big argument actually with someone at the moment about whether it's fully inconsistent with quantum field theory, so I won't get into details, but I'll just discuss the multiverse interpretation. So this says that each quantum event of the universe branches, so every possible outcome exists in one of those realities. So you get a gradually expanding multiverse. And this system is deterministic, which was the main issue that I had. It removes the problem, but it's not a particularly palatable or natural solution. And it's not something you can ever have any direct evidence for. So if we compare this to the days of classical mechanics, then you had this nice philosophy, the mechanical philosophy, which seems to be perfectly consistent with physics and which seems to imply certainly deism and perhaps atheism. So the atheist had this really natural way of looking at the world, which seems to be consistent with science. So in those days, things were easy. It was easy to be an atheist. Now, you've got to start thinking about in terms of multiverses, or saying that the universe is not rational, that there's some things which can't be explained. And I think it becomes much harder to be an atheist today than it was, say, a bit over 100 years ago, before quantum physics start coming out. And that's, of course, beside all the other evidence for theism, such as from revelation. The theist, on the other hand, has gone in the opposite direction. So 150 years ago, there's this philosophy of science which is broadly incompatible with theism, but was a very natural fit with the science. I won't say it's completely incompatible with theism, determinism. If nothing else, classical physics is just a particular limit of quantum physics. So if you have a good working philosophy of quantum physics that you're comfortable, consistent with your theism or atheism or pantheism or whatever, then you can use that also as a philosophy of classical physics, but it doesn't work the other way around. So classical physics certainly isn't inconsistent with theism, but you've got this more natural philosophy of mechanism, which makes it a bit harder to be a theist because there's this rational alternative to theism which you have to refute somehow, and the way to do that would be through science, but the science was on side with it. And also there are various arguments based in part on this philosophy which seem to go against theism and classical theism in particular. But again, those arguments, the physics they're based on is now undermined. So we can look at those arguments and say, no, that premise of them is, they're based on that premise taken from science, but that science was wrong. There's a better science out now. And you find that most of the arguments used to oppose theism, they're actually the parts of classical physics which were overturned when we came to quantum physics. So I'd say it's much easier to be a classical theist now, or a scientifically informed theist now, than it was 150 years ago. Not to say it was impossible 150 years ago when classical mechanics was around. There's still problems in classical mechanics, a problem for mind, for example, and free will. So there is some room there for theists to maneuver. But I'd say that it is much easier now than it was then.
Well, Nigel, I want to thank you for doing this interview with Intellectual Conservatism. I enjoyed every minute, every second of it.
Okay, thanks.
Nigel, is there anything you want to say before we go to the audience?
No, other than I hope I didn't bore you too much by going into all that detail.
Oh, they'll love it. Don't worry.
Okay, but no, otherwise, thanks for listening. So as you said, I've got one book out, which you're welcome to look at. It goes into much more detail. Requires quite a bit of mathematics, I'm afraid, but so it might be, some parts of it will be a bit difficult to follow if you're not mathematically informed. But you're welcome to look at that. You're welcome to look at my blog, which talks about various random things, but often on this sort of theme that we've been discussing here.
Yeah.
So, anyway, thanks for inviting me on anyway.
Yeah, Nigel's blog is the Quantum Thomist. So yeah, definitely check that out. Thank you so much, Nigel.
No, thank you.